Hello viewers, we will discuss the relation between differential and integral equation, but we will discuss it in a particular case, that means second ordered differential equation. That means we write it the second order differential equation in first degree d square y dx square plus a1x dy dx plus a2 of x y equal to z of x. This is the first degree and second ordered differential equation with the initial value problem. That means y of 0 equal to c1 and y dash of 0 equal to c2. Now considered phi of x be a continuous function and d square y by dx square equal to this. Then we can write it dy dx integrating both sides, that means 0 to x, and that is 0 to x phi of t dt. We use it a dummy variable and change it the dummy variable. Putting this, so ddx of y, and when putting this 0, that means y dash of 0, so y dash of 0 equal to minus c2, that means minus c2, so phi of t dt. If we write this clearly, then this answer would be written as ddx of y equal to 0 to x phi of t dt plus c2. If you integrate this with respect to x, then we can write y integrating limit, that is 0 to x, and there are two integral sign phi of t dt 0 to x and 0 to x. If this is x1, then we integrate with respect to x1, and the final result will be shown with respect to x and c2x. This can be written as, that means y minus y naught, that means c1, so c1 equal to here we see that this is a double integral, so we can write it the single integral x minus t phi of t dt and plus c2x. So we find d square y by dx square, that is phi of x, ddx of y equal to 0 to x phi of t dt plus c2, and y equal to this. So we replace it in here, that's we find, that means this will be written as phi of x, so plus a1 of x, that is the values of ddx of y, so integrating limit 0 to x phi of t dt plus c2, this is, and a to x, and there are another results, that means integrating limit 0 to x x minus t phi of t d dt plus c2x plus c1 equal to z of x. So putting these results, we get it. Now if we calculate it, So now putting the values of d square y by dx square, that means phi of x, and a1x and dx of y, that means integration 0 to x phi of t d dt, plus c2 plus a2x 0 to x phi of t x minus t ddt plus c2x plus c1 equal to z of x. So we find an integral equation as this form. If we rewrite this, phi of x equal to f of x plus lambda 0 to x kernel x comma t phi of t ddt in this shape, where f of x equal to, without integrating parts, that means we get and integrating parts, there's as usual g of x and minus a1x c2 and another minus a2 of x c2x and minus a2 of x c1, and kernel that means k of x t equal to the coefficient of phi t, that means the phi t coefficient of phi t equal to, what's the answer, phi t, that means phi t equal to, here a1 of x and in here x minus t a2 of x, that is okay. And if we write lambda equal to minus 1, then this equation can be written as this form. Now considering a differential equation, very easy differential equation, that means ddx of y equal to y of 0 equal to 1 in here, the initial value. So integrating both sides, we get y 0 to x equal to integrating 0 to x y of t ddt. So we can write y of x minus y of 0, that means 1, and 0 to x y of t ddt. So y of x equal to 1 plus 0 to x y of t ddt. Now we verify these two equations are the same equations. Verify with the y of x equal to e to the power x, which is the solution of this differential equation, because y of 0 equal to 1, that means e to the power 0 equal to 1. So it satisfy the initial condition, and when dx of y you can write, that means ddx of e to the power x, so this is e to the power x. So this solution satisfies the differential equation. Now we can check that now y of t, that means y of t equal to e to the power t, and integrating 0 to x, that means 0 to x ddt. So you can write e to the power t 0 to x, So this answer can be written as e to the power x minus 1. So this is e to the power x minus 1. And starting in a 1, so this 1 or minus 1 vanished, and this is e to the power minus x. This is also e to the power x be the solution of this differential equation and the initial with the initial condition, and y of x equal to e to the power x be the solution of integral equation, this integral equation also, because this integral equation is satisfied by y of x equal to e to the power x. So you get linear integral equation, that means 1 plus 0 to x e to the power t, that means phi of t dt. Now this is the linear integral equation. It is the pattern as this f of x plus lambda 0 to x and the kernel x comma t phi of t dt t. In this shape it is called the linear integral equation, must be Volta integral equation, and second kind also. So this is the linear Volta second kind. But if we write this equation as this pattern, only we sense it kernel of that sense in here only, that means this we can write a power n must be greater than 1, then it is called the non-linear integral equation. So it is non-linear integral equation of Volta second kind. Thank you very much.